Hi, this is Anil. The second unit of data structure totally consists of three data structures: stacks, queues, and tables, that is hash tables. Now we discuss the data structures one by one. Stack data structure. A stack is a data structure based on a principle called LIFO. The LIFO stands for last in first out. Means the item that is inserted at last is the first to be deleted from the stack data structure. So this is the meaning of the stack. So based on a principle called LIFO, the meaning of LIFO, the item that is inserted last is the first
They go on to know that most programming and database languages use variable name to distinguish temporary objects.
Right. Now, if you observe the slide, the icon the array size is 10. So starting index 0, ending index number 9, 0 to 9. 0 is the starting boundary and 9 is the ending boundary. So here totally 4 elements are placed, and after completion of 4 elements push operation, if you observe the top is at the fourth data element, that is 44, and where the index number is 3. So when first insertion takes place, top value 1, and before that insertion top value -1. After first insertion, that is element 17, top is at 1. Sorry, top is at index 0. After second insertion, that is 23, top value 1. After element 97 insertion, that is third element insertion, top 2. After the fourth element insertion, that is 44, top value 3. So like that, the top value, it keeps on goes in an incrementing direction when push operation takes place. And in order to know how many values are present in the stack data structure, it is top plus 1. Why it is top plus 1 means because the index is starting from 0. So the counting of whereas the counting starts from 1. So when the top value is 3, the meaning is number of elements present are 4. So when you perform top value plus 1, that is nothing but the count which says how many elements are present in the data structure. Next, that is regarding push operation. The main thing is here incrementation of top variable takes place as insertion goes on. Next, coming to the decrementation. Now here, if you delete an element 44 from the data structure, then top value is going to decrement, and such that it points to the previous variable, which is index number 2, 97 data item. So like that again, if you perform deletion, it points to the previous data item, that is 23, index number 1. The difference between push operation and pop operation is, in push operation, incrementation of top takes place. In pop operation, decrementation of top takes place.
Next, relationship among objects. For example, consider the object structure.
Right. Now, if you observe here the pop operation, so element 44 is deleted, which is index number 3 data, such that the top is pointing to 2. Previously, the value of top is 3, and after pop operation, the value of top is 2. Like that, if you keep on performing pop operation, finally the top variable becomes -1. So when top value is -1, it says that the data structure is empty. Why it is empty means initially top value -1. So again, starting from some positive value, again it has reached to a value -1. The meaning is that total values deletion is completed, and presently the data structure is empty. And when top value is -1, then no more deletions are possible. Right. And the important thing that takes place, the important thing that we need to notice and observe related to the stack data structure, where you will have a case in the manner. Observe the example. So where in the stack starting portion, that is in the index number 0, 1 and 2, the elements are present, and in the ending portion 6, 7, 8 and 9, the data items are present, whereas there is no data in between 2 and 6, that is in the index locations of 3, 4 and 5. Now this situation arises when we perform insertion from two ends of the stack, from two ends of the data structure, that is from the starting end and from that is at the end, and another from the end, from starting end, and another one from the end corner. Starting means index number 0, lower boundary. Ending means higher boundary, that is n minus 1, size -1. Here the size is 10, so 10 minus 1 means 9. So starting boundary 0, ending boundary 9. And here there are totally two top variables. Top stk1 is one variable which we are using from lower boundary, and another variable top stk2 which we are using from ending boundary. And here the push operation, pop operation, and as well as traversal is based on the total two indicator variables, top stk1 and as well as top stk2.
Who defines it as a physical or conceptual connection between objects. An object collaborates with other objects.
Right. Now, coming to the error checking. Now, in order to perform push operation and in order to perform pop operation and as well as in order to perform traversal, that is displaying of data present in the data structure. So, first, it is based on some conditions. Example, if you want to push an element into the data structure, first we need to verify whether sufficient space is present in the data structure or not. If it is already filled with the data elements, then no more insertion is possible. That is, no more pushing of data is not possible if it is already filled completely. Now, that is called overflow. That is trying to push into a data structure where already it is full, trying to push onto an already full stack, that is called overflow. Next, in order to perform deletion operation, first we need to verify whether is there data present in the data structure or not. If suppose if the data structure is empty and if you are trying to perform deletion, then deletion operation is not possible. Why? Because means it is empty. And when we can say that data structure is empty means when the top variable is initially -1, then we can say that it is empty, and this situation is called as underflow. Means overflow condition we verify when we need to overflow condition we supposed to verify, we have to verify when while performing push operation. Underflow condition has to be verified when to perform pop operation. I am repeating again, push operation need to verify before, sorry, overflow condition has to be verified before push.
State of an object represents the cumulative results of its behavior. Consider the vending machine example. The vending machine.
The operations coming to the data structure stack. Now, what are the operations that we can perform on the stack data structure? Now, here not only regarding stack data structure, related to any data structure, the common operations that we can perform on the data structures are insertion, deletion, and traversal. So, insertion means adding of elements to the data structure, deletion, removal of elements from the data structure, traversal, displaying the elements of the data structure. Now, the operations on stack, they are based on a variable, an indicator variable called as a top. The three operations, insertion, deletion, and as well as traversal, is based on the indicator variable that is top. Initially, the top variable is -1. Why? Because means we are implementing stack data structure using stack. We are implementing stack data structure using arrays. Array index, it starts from 0 to n-1. So initially we consider the top variable as -1, and after insertion of first element and whenever one element is present in the data structure, we make the variable top to point to that element. So that's the reason why initially that value of top is equals to -1. Right. And the three operations, insertion, deletion, and traversal in the stack data structure, they are called as push operation, pop operation. The insertion and deletions are called as here push and pop. Placing of elements is called as push. Removal of elements is called as pop. The top variable initially -1. When first insertion takes place, the variable top incrementation takes place top plus plus such that it becomes 0. And again if you perform insertion, the element occupies the index number 1 and top will move from index number 0 to index number 1. In the same way, again if you perform insertion, that is push operation, the element goes to index number 2. The top variable will increment from 1 to 2. Like that, the top variable, it keeps on changes, that is keeps on goes in an incrementing direction when push operation takes place. Okay.
Next, identity of an object. Identity is the
from the front. Now coming to the second data structure, that is queue data structure. A queue is a data structure in which the item first inserted is the first to delete from the data structure, and unlike stack, here in the queue data structure there are totally two indicators. In the stack data structure only one indicator, that is top, whereas in the queue data structure two indicators, front and rear. Right. Now if you observe the data structure here queue, and the data structure queue using arrays, so means it is a static method. So there are totally 4 elements. The 4 elements are 17, 23, 97 and 44. Here we have to understand the two indicator variables front and rear. The front variable initially -1 and the rear variable also initially -1, means initially both indicator variables front and rear are -1, and whenever the data structure queue consists of only one element, both front and rear indicators will have same value and they point to that one element present in the data structure, and that one element it may be first element or it may be an any element, example index number 4, index number 5, like that. It is not the case that when only one element is present, that should be compulsory index number 0 element. It may be any element of the data structure, example index number, it may be index 4 or it may be index 5, like that. And coming to the two indicator variables, front and rear. Rear indicator variable is related to insertion operation. Front indicator variable is related to deletion operation. So initially both variables are -1, -1. Now first I discuss insertion operation. When first insertion takes place, front and rear both will set to 0. Means both they point to index number 0. Why? Because when first element occupies index number 0. Next, again in the same manner, if we keep on perform insertion operation, example second element 23, third element 97, next fourth element 44. Finally the rear will point to that fourth element which is at index number 3. Means after every insertion the rear indicator variable will increment. In the same as in the stack data structure, the incrementation of top takes place when insertion of elements when insertion goes on continuously. In the same way here, rear variable keeps on increment when insertion operation goes on continuously. So after first insertion, rear value 0. After second insertion, rear value 1. After third insertion, rear value 2. And after fourth insertion, rear value 3. And here also, in order to know the number of elements present in the data structure, we have to use totally two indicator variables, that is front and rear. Whereas in the stacked data structure, just top value plus 1 gives the count of elements present in the data structure. But whereas here it is not like that. Totally the counting of elements is based on the two indicators, that is front and as well as rear. Now coming to the deletion operation. Now exactly opposite when compared with insertion. In insertion, the rear is incrementing. Regarding regarding insertion, the rear indicator is keeps on incrementing. Here the front will keep on increment regarding deletion. Means when you perform deletion, front variable will point to 1. Why? Because means after deleting the first element 17, again if you want to perform deletion, the next element that is supposed to be deleted is 23. And again if you delete again when you perform second deletion, the front will point to 2. Why? Because means after deletion of 23, the next element supposed to be deleted is 97. So front keeps on increment when you deletion takes place continuously. Now this is insertion and deletion operation on queue data structure using arrays. Right now, so one more insertion and deletion I am discussing here. So initially if you observe the queue data structure, it is with 4 elements. 17, 23, 97, 44, where the value of front is set to 0 and the value of rear is set to 3. Now again in this situation, if you perform an insertion, rear will point to 4, index number 4, and in that the value that we are reading, that I am reading, is 333, like that. Next, in this case, if I perform deletion, the first element that is going to be deleted is index number 0 data, that is 17, and after deleting index number 0 data, front is going to set to 1. Why? Because if next deletion is supposed to take place, then the data that is going to delete is index 1 data, that is 23.
Nature of class. A class is a set of objects that share a common structure.
Now coming to the next, the array that I discussed so far, it is called as linear array. Linear queue. Now coming to the next one, the array, the data structure queue that I discussed so far, it is linear queue data structure. Now coming to the another one, circular queue data structure. Okay, we can treat the array holding the queue elements as circular. Then the data structure queue called as the circular queue. Okay, such that if example, where
objects that share no common
the data structure with size 8, such that the highest end boundary is n minus 1 and the low boundary is 0, where if you observe, rear value is 1 and the front value is 5 here. Now this is not the scenario we can observe in the linear queue, where always rear value is high, front value is low in linear queue. Now whereas here reverse is possible, means rear value is low, front value is high. Here rear value 1, front value 5. This particular scenario will not arise in the linear queue. It happens only in circular queue. Why? Because means the array holding the queue elements as a circular, we join the ends, so that the rear will move from 0 to 7 and 7 to 0. In the same manner, the front also, it moves from 0 to 7 and 7 to 0. Elements were added to this queue in the order 11, 22, 33, 44, 55 and will be removed in the same order. And here the conditions or the logical statements in order to perform insertion operations and deletion operations. Here front is equals to front plus 1 modulo division length of the data structure. In the same manner, rear is equals to rear plus 1 modulo division length of the data structure. Now by using these two logical statements, we perform insertion operation and we perform deletion operations. Right. Now coming to the next topic of queue, full and empty queues. Now what is this full and empty queues means? In stack data structure, we discussed two topics, underflow and overflow, where the two conditions we verify related to insertion operations and deletion operations, that is push operations and pop operations. In the same manner, coming to the queue data structure, before performing insertion, we have to verify whether sufficient space is present in the data structure or not. If sufficient space is not present, then insertion is not possible. And in the same manner, before performing deletion operation, and in order to perform deletion operation, first we have to verify whether data structure is consisting of elements or not. If the data structure is empty, then deletion of data is not possible. I am repeating again. Before performing insertion operation, we have to verify whether sufficient space is present in the data structure or not. And before performing deletion operation, we have to verify whether data structure is consisting of some elements or not. Then we can perform insertion and deletion. Now, just now I discussed when you keep on performing insertion operation, the rear variable will increment, and when you keep on performing deletion operation, the front variable will increment.
Like association, inheritance, aggregation, using, differentiation, and metaclass.
Now coming to the in an SLL, that is in single linked list, we can use the SLL. Now this is what the representation. Enqueuing a node. Enqueuing is nothing but adding a node to the list. Now presently the list is with 3 elements 44, 97 and 23. Now to that I am trying to we are trying to add a new element 17, where the node 17 is supposed to appear after node 23. So in order to do that one, first we need to identify where the last node is and what the data is it. Okay. Now we identified where the last node is and what is the data present in that. Next, change it to point to the new last node. Now we are making the node 23 pointer to point to 17. Right? Now we established the connection from node 23 pointer to the node 17. Now, if you observe that initially the node 23 pointer value null. Now, that particular null value is going to be that particular null value we have to set to the node 17, because previously node 23 is the last node. Now, whereas presently node 17 is the last node.
And many to many.
And previously node 23 is the last. Now presently node 17 is the last. So after setting 17 node pointer value as null, that has to be updated in the pointer variable last. So if you observe here, first and last, the two variables. Last is a pointer variable containing the information of last node. First is a pointer variable containing the information of the first node. Now if you use like this two pointer variables first and last, then there is no problem in the operations of insertion and deletion. Dequeuing a node. Now what is meant by dequeuing a node means deleting a node from the data structure is called dequeuing a node. Now here presently the queue data structure is with 4 values 44, 97, 23 and 17. Now so when you perform a deletion operation first time, the node that is first to be delete, the node that is going to delete first is 44. Why? Because means the data structure queue is based on the principle FIFO. The first item inserted into the data structure is 44. So the element that is going to be deleted first from the data structure is 44. So when 44 data element deletion takes place, then 97 element becomes the first element of the data structure. Means first is a pointer variable where presently it is containing the address of node 44. Now before deleting node 44, make the pointer variable first to point to the data node 97 and afterwards delete the node 44. The deletion of node 44 takes place using the function free. So here the process is copy the pointer from the first node into the header. Reason to set deleted to null. Dequeues. Coming to the